Hello and welcome to this LangChain JS course. After this course, you'll be able to use JavaScript with LangChain to develop complex applications with large language models, so-called LLMs, and use them for your own purpose. We will start with a simple introduction to working with LLMs, first without LangChain, and then we look at why LangChain makes your job so much easier. After that, we'll get into the topic of templates and response schemas, look at so-called chains, and output parsers that we can use to customize the output of LLMs to our needs. After these basics, we take a look at more complex chains, so-called sequential chains. Next, we move on to indexes and look how you can access your own knowledge bases and use vector databases to extract data via similarity searches and send it as context to an LLM. Then we take a look at the concept of memory. With memory, LLMs can take into account the context of a conversational history and not always just respond to one direct question. After this, we take a look at a quite advanced concept, the so-called agents, which are able to autonomously perform tasks and use tools to do so. This course is pretty similar to my Python LangChain course, so which one should you use? If you're really interested in AI and LLMs, I would recommend my Python course, since Python is just the language in data science and AI. If you are more interested in web development or front-end in general, but you also like AI and maybe want users to be able to click on your web application, then go for the LangChain course in JavaScript. Or maybe just do both, whatever you want. Okay, now let's start with coding. Okay, I'm currently in VS Code, and as you can see on the left, I've got many files, which include some JavaScript code. This is the code we will use in a course, and I would definitely recommend that you just check out my Git repository and follow along. And of course, play also a little bit with the code, but don't write everything from scratch. To make this code work, you need an OpenAI account and you need an OpenAI API key, which you have to paste here in the .env file. And because this is JavaScript, you also need Node to be installed on your computer. You can do this with Node ---- version. And as you can see, I've got version 18. You should have a similar version, not older than version 16, I would recommend. Okay, let's take a look at the package.json file first. As you can see, we've got 4 dependencies here, .env, because we've got our .env file and we load the key by loading our environment file. Then we install files node. This is the vector store library we will use. Then of course LangChain and OpenAI to make the requests to OpenAI and to actually use the LangChain package. And then very important that you keep the type here to module, because otherwise you cannot use import statements in Node.js but have to use require. And the documentation in LangChain is almost always with import statements, so keep it like this. So now let's run npm install to install our dependencies here and create our node modules folder. And then we can just start coding. Okay, now let's go to the first file, the 00 basics file. And what we're gonna do now is first we import the config from .env and then we run the config function, and this will load the API key in our environment and we can use it. And then we import configuration object and the OpenAI object from OpenAI. After this, we create a new configuration object and we pass in as API key the process.env, and then this is the OpenAPI key from our .env file. And this is the way we can access it. So now we have a configuration object with our API key, and now we can make a request to OpenAI. So what we're gonna do now is we instantiate the OpenAI API class from OpenAI, pass in the configuration to the constructor, and then we get our OpenAI instance. Okay, now we will create a little helper function called chat, and this will get a single input, which will be a string. And this is very important. This is the messages we will send to OpenAI. It has to follow this data structure. We have to send an array of messages, and in the array there have to be objects, and the key first has to be role. And if we want to make a request with the user, we call it here user, and the content has to be a string. Besides user, the most important role is assistant, and this is the role which is responsible for the response from OpenAI. So we've got the conversation, always user and then AI, user and AI. So this is the whole conversation stored inside this messages array. And then we send this messages array to OpenAI. We have to do it with the create chat completion class. We have to pass in here the model we want to use. So in this case, it's GPT 3.5 Turbo. Quite powerful and very cheap. Then we pass in the messages and then the temperature. The temperature is a value from 0 to 1, and 1 means it's very dynamic in its output, so maybe a more creative chatbot, and 0 means it's very robust, deterministic, and you can play a little bit with the values. What you want depends on your use case. The response which we get back here from OpenAI is a complex object, and we actually have to retrieve the correct information. So we have to retrieve a data property and then the choice property, which is a list. We have to extract the first element, then again the message property, and then the content property from that object. And this actually returns only the text which we get back from OpenAI. Okay, now let's use the function, and first we will create a question: what is the capital of France? And the LLM should be able to answer this. So we will pass in the question here to the chat function, and since this is an async function, we will have to resolve the promise which we'll get back and then just console log the response. Otherwise, if that doesn't work, we will catch the error. So now let's run node 00basics.js and of course save it here, and then we get back the capital of France is Paris. Okay, that was the most basic use case. Normally when you use an LLM for your own use case, you give it some kind of identity, and to do it you normally give it a kind of system prompt, and I will show you how to do this. For example, this is the prompt template and this is some kind of variable here. So what we want now is be very funny when answering questions, and then you have got here the question, and the variable here will be replaced by the actual question. Yeah, you could also use a $sign here to actually have some real variable, but this is the way LangChain does it, and we're gonna use it this way too. So now we can replace here the question just by a string replacement and actually pass in the correct question, and then we run the chat function again, and then the bot or the LLM should now behave differently. Okay, as you can see, the answer is now the capital of France is obviously France. Just kidding, it's Paris. Okay, as you can see, this works, but LangChain makes this process, which we've done here manually, even easier. And we will now take a look at the first chains. Okay, I'm here at the first chains.js file, and we also will just import the config from .env and run this config function. And then we will import the OpenAI class, but now we don't import it from OpenAI, but we will import it from LangChains, LLMs, and then here from the OpenAI module. And then we will also import the prompt template from LangChain prompts, and then also the LLM chain from LangChain chains. To use it, we have to instantiate the OpenAI class. We also pass in a temperature here, and then we've got our model instance, and then we create a template. This is the same template we created before. As you can see, we have to use these curly braces inside the template, and to use it in LangChain, we have to create a new instance of prompt template, pass in the template here as argument, and then also the input variables. And then, as you can see, we've got question as input variable, and this name here has to match the name inside the curly braces. And this will automatically create the complete template at the end. And then we create a new LLM chain. We pass in the LLM, which is the model here, and then we also pass it the prompt. Now we've got a chain object, and to the chain object, we just run the call function here, and we pass in the question as object, what is the capital of France? And this should already behave in a funny way. We can just run it, node, and then first chains.js. Okay, again, we get back some kind of joke, but as you can see, we don't have to pass in these kind of message object with role and content and so on. We just have to pass in the question as object, and this makes it very easy to work with OpenAI and LangChain. This is the most simple chain we can have. We have one input variable and we pass everything to the LLM and get a single output. We could also pass the output from this call here to another LLM chain, and to do so, we can use a simple sequential chain. If we have multiple input variables, we have to use the normal sequential chain. I will first show you how to use the simple sequential chain. So again, first we make the inputs and we import, besides the normal LLM chain, the simple sequential chain, and we of course also import OpenAI and the prompt template. So now we create an LLM, just instantiated with the OpenAI class again, and then we create the first response template. You are a helpful bot that creates a thank you response text. And then we create another template. You are an assistant bot. Your job is to make the customer feel heard and understood. We've got a single input variable here for both templates called input, and now we will create a prompt template. So we will instantiate the prompt template class, and we do this for the second template too. Now we have got two review prompt templates, and we will first then create a review chain for the first template, and then we will create another LLM chain for the second template. So what we can do now is we combine the review chain 1 and the review chain 2 to a single chain. And we do this by instantiating a simple sequential chain. We have to pass in the chains in the order we want to call them. So first we want to call the review chain 1 and pass the output then to review chain 2. And this is just to see a little bit more information what's going on under the hood. This overall chain instance now has got a run method, and since this is async, we have to await it, and then we will get a result back. So we make one single input. I ordered pizza, salami, and it was awful, but it will make two LLM calls under the hood. First the review chain 1 and then the review chain 2. So, and then we get a final result, and we will just log the final result. Let's run it here, simple sequential chain. And here is the first prompt. We're entering the LLM chain. And then we see the second prompt, and we can see this is the final output. I understand that it has been an inconvenience to you. Is there anything else I can help you with? So that's the final answer from the bot. And as you can see, you can chain as many LLM chains as you want, as long as you've got a single input variable for them. If you've got multiple input variables, that does not work. And to solve this, there are sequential chains which make use of output keys. I will show you how to do this. First, we'll of course input every class again, then we instantiate our model, the LLM, and then we will create our first template. Here you see the template has got two variables. You ordered dish name and your experience was, for example, awful. Please write a review. So this is the first template. It has got two input variables. And now we create a prompt template for this, and we've got, as before, here we can see our two input variables, and we also have to pass in here two input variables in the array. Then we've got our first chain. We pass in the LLM, pass in the prompt, and now we pass in an output key. So this is important for the LLM to know to which chain it should pass the output created from the first chain here. So now we create a second follow-up template. As you can see, the output key matches the input variable from the second chain. So here we've got our output key, and it matches again the input variable. So this is our second chain. Okay, then we've got the second chain, and then we will create a third template. Again, this will be with a review variable, so we will pass in the output here to this template too, and we will create a third chain, and the output here is summary. So what we're going to do now is we create a last chain, and we want to pass the output from the summary chain to this template here. So we want just to translate it to German, and then we will create a last chain. So we've got 4 chains now with different output keys and different input variables. The names are different, and also the amount of input variables are different. So what we're going to do now here is we create with the sequential chain an overall chain, and we pass in the chains as array, the review chain, the comments chain, summary chain, and translation chain. We have to name the input variables, and these are just from the very first template, dish name and experience. So no other input variables like review or, for example, summary, only from the very first template. And the output variables, as you can see, these are review, comment, summary, and German translation. These match the output keys here from our chain. And this is our complete chain. And now we will call again the call method here, and we pass in the dish name, we pass it here as an object, pizza salami, and experience it was awful. And then we will log the result. So let's run node and then SequentialChain.js. Okay, that works. As you can see with sequential chains, you can even chain chains with different input variables and pass them around with output keys. LLMs normally only respond with text. Sometimes this is not what you want. For example, if you want a review and you want to see if the review was positive, negative, or neutral, maybe you want some kind of object which you can just copy and pass in, for example, to MongoDB. This is not possible with text, and you need some kind of JSON format. And to do so, you need an output parser and some special kind of prompt. To achieve this, we can use response schemas and output parsers. I will show you how to do this in this file. And again, we import OpenAI and prompt template. And now we will need another class called structured output parser. And this allows us to parse text to some kind of dictionary or object. So from this structured output parser, we call a class method called fromNames and descriptions and pass in an object called answer. And then we want as value answer to the user's question. So this is what the behavior we want from our LLM. And then we call the getFormatInstructions method of the parser and get back some kind of text here. I will show you how it looks like. We just run node and then the parsers file. And of course we don't want the response here, but we want the format instructions. So let's run that again. As you can see here, the structured output parser tells the LLM it should respond with some special kind of JSON object form here and with type and some kind of properties. And this already comes from LangChain and helps us or tells the LLM that it should not respond with normal text, but it should respond in a JSON format, which is easily to convert to some kind of object in JavaScript. We can take these format instructions and pass it to our prompt template. We can do it like this, where we will instantiate the prompt template and pass in format instructions as variable. We also pass in questions, and now we've got two variables. We've got the input variables here, which is just a single input, but we have to pass in an array of variables, and then we've got partial variables. This is only necessary when we pass in these format instructions. So we do it like this, we pass it as an object, and then we will create a new model instance with calling new OpenAI. After instantiating this, we will run the prompt.format method here and create an input variable, and we pass in the variables inside the normal input variables. We will not pass in the partial variables, and then we call it here, and then we've got this input object, and we pass in the input object to the call method of the model, and we will await the response, which is just a string. It is not a JavaScript object. We have to call the parse method of the parser to convert that string, which looks like a dictionary or a JavaScript object, to a real JavaScript object. Then we'll just save it and run it. So let's try that. I have to again to delete it here. Okay, now we can see what is the capital of France. And as we can see here, this is just a string, but our parser is able to parse this string here to a real JavaScript object. And we could now take this object, for example, and pass it to a MongoDB. Okay, so far we only used knowledge which was already trained in the model training. But in many cases, you want a chatbot to use your internal knowledge base. For example, you've got some kind of database and you want to retrieve data from the database and use the retrieved data and convert it to some kind of human-like text output. You could query the whole database and pass in the whole output to the prompt, but the problem is that could be quite expensive because you pay per tokens and you could reach the maximum tokens. For example, the older models like GPT 3.5 Turbo has got 4,000 tokens max. The newer models have got 32K, but still it's limited. If you've got a large knowledge base, these input limits are still a problem for you and have to be overcome. So I want to show you how to overcome this in a kind of easy example. And we've got this restaurant.txt where we've got some answers and questions. So this might be a use case for a typical Q&A bot where a user asks some questions to the bot and we want to extract the knowledge which answers the user's question by actually making a similarity search on the text and giving back the correct answer for his question, the LLM, and let the LLM take the text and actually make a real good and useful answer from this output. So we cannot just take the whole text and store it inside some kind of database. We have to store bit by bit because this has different meaning than this, and this has got a different meaning than this. So we have to store this, and to do this, we actually have to split this text element, this text file, in multiple chunks. And this could be a chunk, this could be a chunk, and this could be a chunk. LangChain offers a standardized way, and we actually will create now chunks from this. And we can also not just put the chunks in the vector database. We first have to convert the chunks to so-called embeddings And what embeddings are is kind of easily explained by the OpenAI website. Here's the website. And as we can see, here we've got text, and this text will be passed to a so-called embedding model. The embedding model is responsible for converting the text to a vector. A vector is just a representation of text as numbers, as a list of numbers. And now you can store this list of numbers, the so-called vector, inside a vector store. And for example, this looks like this. There's even a better explanation down there. So we've got similar vectors stored in similar places in the database. For example, vectors which belong to animals are stored in this space, and vectors which belong to athletes are stored here. And then we make a query to the database, and the query gets also embedded, and now we make a similarity search. For example, we want to get the top 5 similar vectors in the vector database. And we also know which vectors belong to which text. So we can take the top 5 texts and pass the text as context to the LLM. Okay, now let's do it in code. And first we will go to the indexes.js, and we first will of course import here the config and then the correct classes. And what we're going to import here are a text loader and a character text splitter. We need the text loader to actually load our text file and save it in memory. And then we will create some kind of chunks with it with the character text splitter. After this, we have to create the embeddings, and we will use the OpenAI embeddings class for this. And we will store the embeddings in the file store. This is a vector store from Facebook. And so we import the file store here from the files module. So these are all our imports, and we can now create a new text loader instance, a loader, and we will pass in the path here to our file. So this is the current directory, and the file is called restaurant.txt. So this is the loader, and now we can load it. So we load it from the file system in memory and store it in the variable docs. And now we will create a splitter. This is a text splitter, and we will create the chunk size. The chunk size is the amount of tokens. So normally 75 words are 100 tokens. So you can guess this is around 150 words. And we also use some chunk overlap to actually not use the whole context if we split one sentence directly in the middle. So this is very helpful, even though it will make our API call a little bit more expensive. But AI embeddings are quite cheap. So now we can use the splitter and split the documents with the split documents method of the splitter and await this. And now we've got our documents. So the documents have to be converted to the embeddings, and we just instantiate the OpenAI embeddings class. So now we have to call the from documents method here from file store and pass in the split documents and also pass the embeddings. And this will create our vector store, and we can save the vector store on our disk with the save method of the vector store instance. So we just gonna call this now. So node indexes.js. As you can see, here are our documents. This is a class with a property called page content, and these are many splitted documents here now. And these are all stored now in the vector store. And as you can see, we've got our docstore.json file and our files.index file. So this is our vector store, and we can now use the vector store to run a similarity search. So we convert a question to a vector and run a similarity search to the database, and we retrieve the most similar documents from the vector store. How to do this, we will learn at the useStore.js file. So inside this file, we of course have to import the config function again. Then we have to import the OpenAI embeddings class, FileStore, and OpenAI. And in addition to this, we will load another chain class here, the RetrievalChain. Perfectly fine for retrieving data from a vector store. And we also import here the load Q&A stuff chain. This is a helper function here we also have to use for the retrieval Q&A chain. We also have to instantiate the OpenAI embeddings class because we will convert the new query from the user to a vector too, and then we'll run a similarity search with this created vector against the vector store. So then we will load the file store with the file store load method here, and we also will need the embeddings instance here to actually create the embedding for our question. Okay, then we of course need a model too, and then we will instantiate our new chain, the RetrievalQA chain. We have to pass in an object here, a combine documents chain, and this is where our helper function comes in handy. We have to use the load Q&A stuff chain and pass in the model as argument here. And then we also need a retriever. This is the vector store, and the vector store can be converted to a retriever, which makes it easier to retrieve documents from the vector store. And then we also want to return the source documents here. And now we will run the call method with the query, when does the restaurant open on Friday? So this is something which was not trained in the LLM. So the model has retrieved that information from the vector store. And now we will store the result here in this result variable, and we will just log the text of this result. So let's run it. So we get back, the restaurant opens at 11 AM on Friday. If we take a look at the restaurant.txt, 11 PM, as we can see, our restaurant is open from 11 AM, from Monday to Saturday. So this vector was retrieved by the query here and converted to the correct answer by the LLM. And again, to summarize, that's the workflow. You take a question, run a similarity search against a very large database, retrieve the correct embeddings and the documents from the store, and take in the most similar documents and take them as input, so as prompt input to the LLM, and then the LLM will create a final answer. So now let's take a look at memory. So why do we actually need memory? Let's say, for example, you talk to a friend and you ask him how his holiday was. You ask, how was your holiday in Paris? He answers, it was very nice, great food, and so on. And then you ask again, can you recommend a restaurant there? If your friend had no memory at all, the there wouldn't make any sense to him. And if you don't provide memory to an LLM, this is exactly the case too. The LLM would now lose the context of the whole conversation and only be able to respond to one single question. And normally, if you've got a chatbot, you don't want that. You want to remember the history and not lose the whole context of the conversation. That's why we use memory. Okay, now let's have a look at the chat.js file. We import the config function and then we import a new chain, the conversation chain. This is a chain perfectly suited for holding a whole conversation with memory. And then we import the chat OpenAI class, also a class perfectly suited for a chatbot. So now we also import some helper functions. These are not too important, just some kind of new prompt templates. The more important stuff is here, the buffer memory class, and the buffer memory class is able to hold the memory of the conversation with in combination with a chain. So now let's use it. We create an instance of the chat OpenAI class. Okay, now we will create a prompt for the chat instance here, and we will use the class method from prompt messages here, and we will set a system message. This is the identity of the bot. And now we will also create a new placeholder, and this is the history. This is needed for the buffer memory, and we also create a human message prompt template with just a single input variable, because we will just input text there, and then the buffer memory will store the whole conversation in memory. So let's try it. We will create a new chain with the conversation chain class, and we pass in an object here, memory, which will be an instance of buffer memory. And we will set the memory key to history. So this memory key matches this placeholder variable. Then we pass in our prompt, and the prompt will be just this chat prompt, and the LLM will be the chat OpenAI chat instance here. So this is our LLM. We pass it here. Now we've got our chain, and we can just call the chain. So what is the capital of France? And we want a response for this. And then we want to make a follow-up call. What is a great place to see there? And there only makes any sense if the LLM knows that we talked about France before. So let's console log here the response to see if that actually worked. And now let's wait for the final answer. We'll make 2 requests to the API. That might take a bit. There are many great places to see in Paris. So the LLM knows that we just asked what is the capital of France, and the answer was stored because Paris is true, and there actually relates to Paris. So as you can see, this works, and this buffer memory takes care of tracking the whole conversation, and you actually as user only have to run the call method with a new input. So very easy to build memory inside your own chatbot with LangChain. Okay, let's look at the last concept, and this is a very powerful concept, and this is the concept of agents. Agents are LLM calls which work like a recursive function, so a function that calls itself over and over again until it gets to a final answer. So I'm going to show you first how this works, and the LLM uses a special React framework under the hood. So this has nothing to do with the React framework in JavaScript. It stands for reason and act. And as you can see, the input of a user is split into thoughts and actions. So the LLM is forced to think about an optimal strategy to solve that problem. And for example, if one of the tools is a calculator, it will use the tool to get the correct answer. There are many tools in LangChain already built in. Many of them require an API key, so we will use the calculator example, and I will show you that in code now. Okay, first we import the config again, then we import the chat OpenAI class. This will also be used for an agent, and then we use the initialize agent executor with options function to create an agent. And then we also import some kind of tool here, and we import the calculator tool. We also have to set an environment variable here called LangChain handler, and we will set it to LangChain. And now we will create an instance of the chat OpenAI class, as we're used to do so. And we will also instantiate the calculator. We store that in an array, the instance of the calculator, because the agent expects an array of tools. Now we can call the initialize agent executor with options function, pass in the tools as argument, and also pass in the model. We pass in the chat conversational React description, and this agent type makes use of this React framework I just showed you. Okay, now we can run the executor. We will ask what is the capital of France, so nothing math related. And then we will just call the call method of the executor and pass in the input here, and then we get back a result. So before actually running the code, we will just create another input here. What is 100 divided by 25? So this is something we should be able to solve with a tool, and this should be solved without a tool. Then we can just call the call method again and pass in the input, and then we will just log the result. Okay, now let's run it, and we can see the agent in action. So let's try it. As you can see, here is the prompt template from the agent, and it works its way through. We get a lot of output here, much more than in Python. And okay, pretty hard to see, but at the end we can see here the result of 100 divided by 25 is 4. So it got it correct, and I'm pretty sure it used the right tool to achieve that goal. Okay, that's it from this introduction to LangChain. If you liked the video, feel free to subscribe to my channel and give the video a thumb up to actually help me with the algorithm. Thank you very much. Bye bye.